Tomorrow, an astronaut will step outside the International Space Station for the first time in a mission that is more than a routine maintenance job. ESA astronaut Sophie Adenot is scheduled for her first spacewalk on August 18, 2026, and the event offers a rare look at how humanity works in the most hostile environment we have ever entered. A spacewalk sounds simple when described in one sentence: open a hatch, climb outside, and repair or install equipment. In reality, every movement is planned around vacuum, radiation, extreme temperatures, limited oxygen, and the unforgiving geometry of a spacecraft moving around Earth at roughly 28,000 kilometers per hour. The spacewalk will take place outside the International Space Station, a laboratory that has been continuously occupied for more than 2 decades. Its giant solar arrays, radiator panels, truss segments, cameras, and science platforms form a complex machine assembled piece by piece in orbit. Adenot's first extravehicular activity is part of a wider European presence in space. ESA astronauts do not simply visit the station, they contribute specialist skills in robotics, engineering, science, and operations. Every spacewalk is a demonstration of teamwork between the people in orbit and the flight controllers on the ground. Before the hatch ever opens, the astronauts spend hours preparing their bodies. They breathe pure oxygen through a carefully controlled procedure that helps remove nitrogen from the bloodstream. Without this preparation, the pressure change from the station to a spacesuit could cause decompression sickness, the same basic danger associated with divers surfacing too quickly. The spacesuit is not clothing. It is a miniature spacecraft wrapped around one person. The suit maintains pressure, provides oxygen, removes carbon dioxide, circulates cooling water, protects against micrometeoroids, and gives the astronaut a communication system connected to the station and mission control. Inside the suit, a liquid cooling garment carries water through narrow tubes next to the skin. This matters because space has no air to carry heat away in the ordinary way. In direct sunlight, surfaces can become intensely hot; in shadow, they can become extremely cold. The suit must manage both conditions while the astronaut works. The backpack, formerly called the primary life support system, supplies the essentials. It contains oxygen tanks, fans, carbon dioxide scrubbers, cooling equipment, batteries, and communications hardware. If the tether were ever lost, the astronaut could use a small emergency propulsion system to return to the station. That emergency system is rarely needed, and the entire purpose of planning is to make sure it remains unnecessary. Astronauts are attached to the station by safety tethers, and many tools are secured with retractable lines. A dropped object does not fall toward Earth immediately, it enters its own orbit and can become a hazard for the station. The most surprising challenge is not floating. It is stopping yourself from floating. A person outside the station has no floor, no wall, and no obvious sense of up or down. Handrails become the path. Every grip, push, and turn must be deliberate, because an accidental movement can send the astronaut drifting away from the work site. The station is designed with thousands of handholds and attachment points. Astronauts move along them slowly, keeping 3 points of contact whenever possible. A task that might take minutes in a workshop can require careful choreography in orbit, with the body positioned so that a tool can be used without creating an unwanted rotation. During Adenot's spacewalk, the objectives will center on station operations and technology outside the orbital complex. These tasks may not produce a dramatic image every second, but they are essential. Space stations are exposed to atomic oxygen, radiation, thermal cycling, and tiny impacts, and their hardware must be inspected, upgraded, and tested continually. External experiments are especially valuable because they experience the real space environment directly. Instruments placed outside the station can measure radiation, observe how materials age, examine the behavior of biological samples, or test technologies intended for future lunar and deep space missions. A spacewalk is also a time experiment. The station circles Earth again and again, passing from daylight into darkness about every 45 minutes. An astronaut may watch sunrise and sunset repeatedly during a single excursion, while the suit systems and the mission timeline must remain stable through each thermal transition. The visual experience is difficult to imagine from Earth. Below the astronaut is a curved planet, not a flat map. The atmosphere appears as a thin blue line, a fragile boundary between the vacuum above and every ocean, forest, city, and human life below. The station's metal structure can fill the foreground, while half a continent slides silently beneath it. There is no sound in the open vacuum. The astronaut hears fans, pumps, breathing, and radio voices through the suit, but outside the suit there is no air to carry a sound wave. A tool can strike a handrail, yet the vibration reaches the astronaut through metal and gloves rather than through the surrounding darkness. Those gloves are one of the limiting factors. They must protect the hands and maintain pressure while still allowing the astronaut to feel and manipulate equipment. Fatigue builds quickly. The hands, shoulders, and forearms do much of the work, and small adjustments can become exhausting after hours in a stiff suit. This is why spacewalk training takes place underwater. The neutral buoyancy laboratory gives astronauts a full-size mock-up of station structures and allows instructors to study each motion. Water does not perfectly reproduce microgravity, but it creates a useful environment for learning how to translate along handrails and manage a bulky suit. Astronauts also train in virtual reality, aircraft, simulators, and procedure rooms. They memorize emergency responses because communication can become busy and visibility can be limited. If a cooling loop shows a problem, if a visor fogs, or if a tether behaves unexpectedly, the crew must react without improvising the basics. The first spacewalk is therefore not a solo adventure. It is the visible end of a long chain of engineering. Designers, suit technicians, instructors, medical teams, robotics operators, controllers, and the astronauts themselves all contribute to a single sequence that may be watched by millions of people. The International Space Station makes this collaboration possible on an international scale. Its modules and systems were supplied by multiple space agencies, and its crews have learned to work across languages, institutions, and technical traditions. Orbit turns cooperation from an abstract idea into an operational necessity. For Europe, Adenot's mission is also a milestone in a new generation of human spaceflight. ESA astronauts are increasingly involved in long-duration missions and advanced operations, building experience that will matter as agencies prepare for sustained activity around the Moon. The Moon is only a few days away, but it is a much harsher destination than low Earth orbit. There is no large station to provide a familiar safe haven, resupply is slower, and communications can be delayed. Lessons learned while maintaining the station can influence the design of lunar habitats, suits, tools, and procedures. A spacewalk is a reminder that exploration advances through ordinary tasks performed in extraordinary places. Tightening a connector, routing a cable, installing an experiment, or checking a surface may sound mundane. Yet each task extends the ability of humans to live and work beyond Earth. There is also a philosophical dimension. For most of history, the sky was unreachable. Today, a person can open a hatch and stand above the planet, held to a spacecraft by a thin line and a carefully engineered suit. The technology is astonishing, but the vulnerability remains visible in every movement. As viewers watch the live coverage, the most important details may be easy to miss. Look for the slow hand-over-hand movement, the constant tether management, the changing reflections on the visor, and the way the astronaut's body stays aligned with the structure. Spacewalking is precision under pressure. The upcoming excursion is not just about one astronaut's first step outside. It is about the accumulated knowledge of thousands of people, the continuing value of the International Space Station, and the preparation of a civilization learning to operate away from its home world. When the hatch closes and the airlock is repressurized, the achievement will not end. The data from the equipment, the condition of the suit, the efficiency of the procedures, and the experience gained by the crew will all feed into future missions.